Hello, 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 hello. Bismillahirrahmanirrahim. Uh, my topic with examples of vertical curve design is continuing. Today we will solve example 3.5. Uh, this is a very basic problem in which you have been given a curve, vertical curve, uh, crest vertical curve plus 1% and minus 2%, and you have to calculate its length uh, that can accommodate 70 miles per hour design speed. So as usual, we'll generate the data. 1 plus G1 is 1%, that is 0.01, G2 is minus 2%, minus 0.02, and V is equal to 70 miles per hour. In order to design a curve, to calculate the length of the curve, AASHTO has given these two relations, and these two relations are as follows. Or the first relation, as you can see on your screen, is about when we assume that SST, safe stopping side distance, is less than the length of the curve. So then you will use this relation, and where A is the algebraic difference of the grade, it's the algebraic sum of the grade. And then the stopping side distance, if stopping side distance is greater than length of the curve, then you will use this relation. That's 2s minus 2158 about A. And if you want to know the curve, and this actually this portion, if I can draw, let me draw this thing. If I can draw this thing, I mean that this portion, let me highlight this portion. Sorry about my, no. If I can highlight this portion, this is actually the SSD square or 2158 is can be considered as K, and then the rest is A. Similarly, if I have to be like this is, you can say, 2 SSD is can be considered as K, and this whole thing can be K, and then it's A. So, first, for conventional, we say we have to find SSD, and we know what is SSD, how it is calculated. So, this SSD comes out to be 755.49 feet. And if I assume that length of the curve is less than SSD, that I mean SSD greater than L, I find the length as 719.3 feet, 791 feet. But my so if I compared with SSD, SSD is 755.49. So my assumption that length of the curve is less than SSD is wrong. So this is not the actual length of the curve. Because if it would have been the actual length of the curve, then my calculated length should have been less than the SSD. So what we do next is apply the correct relation, and I found this time 794 feet. And now this again, 794 is greater than 756 feet. So our assumption is correct. So the length calculated from the second formula is actually the length of the curve. So this is the thing we need to understand. It's very simple. Another way of solving this problem is very simple. What you need to know is to use this table that has been given in AASHTO 2018. That's table is 3.34. And from this table, you have 70 miles per design hour speed, and it gives the K value. So it's 247. So K is 247 and A is simply 3. So you will find this K value is the length of the curve is as 741 feet. It's amazing that this curve is actually what uh, it's not what we have designed, and then it looks that this length of the curve is less than safe stopping side distance. So this can be the length of the curve. At the bottom line, you can say there cannot be a single answer for the design of curve. And what you do as an engineer, instead of taking 741 feet, 758 feet, take it some rounded figure like 750 feet and 800 feet. Because the larger the length of the curve, the more flatter it will be. And the more flatter it will be, it will give you more conservative side of safe stopping side distance. So this is example 3.4. Now, this ends my small lecture on this example. So thank you very much for taking your time out and taking this.